Hello and welcome to this tutorial. I've created a 3D model using Meshy and I've rigged it in Blender, where I created 3 different animations. In this video, I will show you how to animate the 3D model on the web using GSAP. I hope you will enjoy the video, and if you have any questions, let me know down in the comment section. The starter setup is very simple. It includes a JavaScript file, a CSS file, and an HTML file. We will begin by working on the HTML. In the HTML, we add a canvas element with an ID along with 3 section containers. Next, we move on to the CSS file. For the HTML and body element, we apply overflow X hidden and set cyan gradient as the background. The canvas is styled to take up the full viewport width and height and is positioned in the top left corner using position fixed. Each section is styled to fill the entire screen, both in width and height. Finally, we check to make sure everything looks good in the browser. In our JavaScript file, we start by querying the canvas using its ID. Next, we create an object to store the viewport width and height. These values will be used frequently throughout the code. Then, we create the WebGL renderer, enabling both anti-alias and alpha, and we assign our canvas to it. After that, we set the pixel ratio. I like to use the math_min function to cap the pixel ratio at 2, which helps maintain good performance on high-resolution screens. Now, we can set the size of our renderer using the sizes object. With that done, let's move on to creating our scene and camera. We first create a new scene. This scene will act as the container for all the objects, lights, and camera in our 3D environment. We will use a perspective camera with a 45-degree field of view, the same aspect ratio as our renderer, and appropriate near and far clipping planes. Next, we create a method called render. In this render method, we call this.renderer.render, and in the parentheses, this.scene, this.camera. This draws the scene from the camera's point of view onto the canvas. Now, we create another method called SetupExperience, where most of the 3D logic will live. To start the animation loop, we use this.renderer.setAnimationLoop and in parentheses this.render.bindThis. This tells the renderer to continuously call our render method on each frame. We use .bindThis to ensure that this keyword inside the renderer method still refers to our class instance. Now, let's test if the renderer is set up properly and check whether we can see a 3D object in our scene. First, I will create a mesh basic material. then a box geometry. I will combine them into a mesh called box. And finally, add it to the scene. We also shouldn't forget to call this method inside the constructor, so it runs when the class is created. Before testing it out, I will set the camera's position and make sure it's looking at the center of the scene using camera.lookAt. Now, let's check it out in the browser. The renderer seems to be working fine, but when we resize the screen, it doesn't seem to adjust correctly. To fix the issue, let's create a resize method. First, we update our sizes object with the new window dimensions. Then, we update the camera's aspect ratio using the updated sizes. We call camera.updateProjectionMatrix to apply the changes. This tells the camera to recalculate its internal projection based on the updated aspect ratio. Finally, we update the renderer's size to match the new viewport. Now, let's go back to the constructor. Here we add an event listener for the resize event and call our resize method inside it. We need to bind the method to the class instance to make sure this keyword refers to the correct context. The scene is being resized properly. We can now start working on loading our 3D model. We need to instantiate the GLTF loader in the constructor. Next, we create a new method that takes a model link as an argument and returns a promise. Inside this method, we use the loader to load the model. The load method of GLTF loader accepts 3 callback functions. One for when the model successfully loads, one for progress, which we are not using, so we will pass undefined, and one for handling errors. Next, we declare variables for the model and its animations. We access the animations from the gltf.animations array. Then, we check if the gltf.scene contains any children. If it does, we assign the first child to our model variable, since that's our actual 3D model. We then loop through the animations and push each one into the model's own animations array. I prefer this approach because it keeps the model's animations stored directly on the model, rather than in the broader scene. Finally, we return the model by calling the resolve function. Before loading the model, let's quickly go back to the constructor and add an ambient light position at the center. This will help us see the texture on our model more clearly. Next, head to the Setup Experience method and remove the cube we previously added. Now, we declare this.robot and load the model from our model folder. Since this is an asynchronous operation, we use async await. Once the model is loaded, I will position and rotate it as needed. And finally, let's add it to the scene. Lovely! It looks like we successfully loaded the model. Alright, now it's time to animate the robot. We will create a new method called Animation Setup to handle all the animation logic. This method takes a model as its argument. First, we check if the model exists and has animations. If not, we return early. Next, we create a new animation mixer for the model, which will manage the playback of animations. We also declare an empty actions object, where we will store all the animation actions by name. We then loop through each animation clip on the model. For each clip, we create an action using mixer.clipAction, clip in parentheses, and store it in the actions object using the clip's name as the key. We also set clamp when finished to true for each action so that the animation holds its final frame when it finishes. Finally, we create an animation data object where we store the mixer, actions, and a placeholder for the current action. This object will be attached to the class for future use. To run the animation, we need to update the mixer on every frame inside our animation loop. We do this in the render method, which is called continuously. There, we access the mixer stored in the animation data and call its update method. The update method requires the delta time. The delta time is the time that has passed since the last frame. To get this, we first go to the constructor and create a new clock by writing this.clock equals new 3.clock. Then, back in the render method, we call this.clock.getDelta to retrieve the delta time and pass it to mixer.updateDelta. This keeps the animation running smoothly in sync with the frame rate. Now, we will create a method called playAnimation to manage animation playback. This method takes two arguments, name and loop type. First, we extract mixer, actions, and current from the animation data object. We check if the action with the given name exists in the actions object. If it doesn't, we log a message. Next, we check if there is a currently playing action and if it's different from the one we are about to play. If so, we fade out the current action to allow for a smooth transition. We then get the new action. We reset it, fade it in, and start playing it. After that, we set the loop type. If none is provided, we default to three.loop_once. Finally, we update the current value in animation data to the new action, so we can track what's playing. Alright, now that we have the animation logic set up, let's go back to our setup experience method to check out the animation names. So I will console log the robot, and let's take a look in the browser's DevTools. First animation is called free fall, the second one is called look wave, and the third one is called sitting. Next, we call animation setup and pass in the model to initialize the animation system. Now, let's test the sitting animation. Okay, that works. Well, let's check another one. This one also works. Perfect. That our animation logic is working, let's implement the scroll trigger. I will import GSAP and scroll trigger from the GSAP library, and then register scroll trigger. Let's scroll all the way down the page. Here, I will create a method called pinScene. First, I will play the look wave animation. Then, I will create a GSAP timeline using a scroll trigger object. I want the animation to be triggered at specific points on the page, but I don't want the animation's playback to depend on the scroll position. It should simply start when we reach certain scroll locations. When we scroll past the hero section, we will trigger the freefall animation. And on reverse scroll, once the animation finishes, we will switch back to look wave animation. Next, I will call the pinScene function inside setup experience to check if it works. Yeah, it's working. I will also add scroll trigger refresh inside the resize method to make sure the timeline updates correctly with the screen size changes. Finally, we will trigger the sitting animation when the user reaches the bottom of the page. And on the Waypack app, we will reset the animation back to freefall. Okay, let's see if everything is working as intended. Seems perfect. Alright, I hope you enjoyed this tutorial. If you have any questions or run into issues, feel free to ask in the comments. I will be happy to help. I would also love to see what you built. Drop a link if you've made something cool with this. Bye bye!